This film is part of a series devoted to glioblastoma research. For over 20 years, there has been no decisive progress in the treatment of this difficult and lethal brain cancer. Few laboratories are investing in research because it remains a relatively rare cancer. Those who devote their time to trying to cure and treat it are all the more deserving. They are the true heroes of our time. They work at the cutting edge of scientific development. Knowledge and techniques are advancing rapidly and must be mastered to understand the defense and resistance processes of this brain tumor. Patients and their family all live in hope of the success of current research. We intend to present some of these, starting with those supported by the Belgian Cancer Foundation. As well as providing information through these short films, we also want to help research. A link under the video will enable you to donate for the Cancer Foundation. If you write glioblastoma as the reference, your contribution will be allocated to related research. The battle is on. We need to support research so that more researchers can get involved. Today we are meeting Professor John Duerinck at AZ Brussels, the VUB's University Hospital, on the 4th floor where the neurosurgery unit is located. First of all, Professor Duerinck, thank you very much for accepting this interview. Could you introduce yourself and tell us about your research into glioblastoma? From what I understand, you are using patients' own immune mechanism to fight and to destroy tumor cells. So far, this approach, from what I know, has not been as successful as with other cancers. Could you tell us a bit more about your approach and your specific approach to overcome this difficulty?
So my name is Johnny Duerinck. I'm a neurosurgeon and a researcher at the University Hospital in Brussels. And since the beginning of my training in neurosurgery, almost 20 years ago now, I was also involved in the neuro-oncology consultations, so providing the medical therapy for all brain tumor patients. And this was always mainly focused on glioblastoma patients because these are the most, this is the most frequent intrinsic brain tumor, first of all. And second of all, for these patients, there's a high unmet need of treatment. So that means that the patients have standard treatment when they are first diagnosed, so they undergo surgery and then radiation and chemotherapy. But then when the patients recur, there's really no standard therapy that has defined or for which it has been shown in a randomized trial that survival is improved. So the research that we did initially was mainly focused on anti-angiogenic treatments, but this proved to not improve survival of the patients. So approximately 10 years ago, we made a switch to immune therapy. And the immune therapy that made the whole field so popular are the so-called immune checkpoint inhibitors. So in tumors like melanoma or lung carcinoma, these are tumors that typically have a lot of mutations and a lot of changes that can be more easily recognized by the immune system. So in those patients, these new medications at that time, which are called the immune checkpoint inhibitors, proved very effective. And so at that point, a lot of trials were set up also in glioblastoma, for example. And it seemed that giving these medications in the intravenous way to the patient is either with a glioblastoma is too toxic for one. If you give the combination of treatment that the patients would need, is too toxic and not effective. So it does not improve survival. It doesn't seem to change anything in the evolution of the patient. So the question then is, why is that? Why is glioblastoma so resistant to immune therapy, and what should need to be done to improve their response to that? Well, it seems that when you look at a glioblastoma, it's a very as we call it, immunologically cold tumor. So that means that there's not a lot of immune cells that are active. There's not a lot of new mutations, because any tumor that has new mutations expresses new proteins on the surface and is more easily recognizable as foreign to the body by the immune system. And glioblastoma doesn't have that. It also prevents the influx of the immune active cells, which we call the T cells. So in that respect, we know that simply giving an intravenous administration of these immune checkpoint inhibitors clearly is not enough. So we started looking into what could be the cause of that, or how we could improve it. And so the blood-brain barrier already is one problem. So that means there's a barrier between the blood and the brain itself, which prevents large molecules from passing into it. And if they do, then it's at a decreased dosing. So to overcome that problem with the blood-brain barrier, and also because we don't want to give too high dosing because that gives toxicity in the rest of the body, we started exploring the local administration of immune checkpoint inhibitors. So that means in patients with recurrence of their glioblastoma, for which we can offer surgery, we perform the surgery, the tumor is resected as completely as possible, and then the medication is injected into the wall of the resection cavity, so directly into the brain. That means that the dosing can be a lot less. It can be kept locally as well, so there's a lot less toxicity and potential better effects also of the treatment. So this was the program that we then started to do in 2017. And so we set it up as an adaptive phase 1 trial, meaning that we were able to change the way we administered the treatment and the dosing in function of how the patients reacted to it. So the whole goal of this whole program was mainly to demonstrate that it was safe and feasible, that this is a potential method that can be used to administer immune therapy. And we're glad to see that a lot of other groups have meanwhile taken over the method, not necessarily to administer immune checkpoint inhibition, but also other forms of immune therapy like oncolytic virus therapy or CAR T cell therapy. So these methods are also more and more being locally administered, mainly to prevent side effects and to keep the dosing of whatever you have to administer low. So we also hypothesized that when you perform a surgery, you also create some influx of immune cells, and the surgery in itself could actually be beneficial for the immune response. So if at that time also you stimulate the immune response, potentially you might get better results. So in terms of results of the study that we have, because I could continue with that, as I said, the main goal of this whole program is mainly to demonstrate feasibility and safety. And this we demonstrated that it is definitely feasible. We also showed in a subgroup of patients from specific cohorts that all patients that responded had a maintenance or an improvement even of their quality of life and their cognitive functioning. So that means that it's not too taxing for the patient to undergo these treatments. It doesn't give too much side effects. It's really generally well tolerated. So that's very important to take into account. That for the patient, it doesn't come across as really too aggressive of a treatment or a method. But of course, you look at feasibility and safety, but we cannot stop ourselves from also looking at how it affects survival. And we see that most of the patients, or on average, the patients do well. And on average, the patients, they do better than a control group that you would take from any historical patients and even from our own studies that we did before. We have a large subgroup of around 400 patients. And we see that for the whole group of patients in this immune therapy study, whole program, and that's around 120 patients, on average, they do better. Of course, we have to admit that this comparison is not entirely fair, because we are comparing patients that can undergo surgery and that did undergo surgery with patients that couldn't. Also, because they underwent surgery, that means that they were fit for surgery. So this might create some selection bias, as we call it, in the patient group that we included for our immune therapy study. So it's promising, but to really demonstrate whether it really affects survival, this should move on into, first of all, a phase 2 study, and then a phase 3 study where you have a comparative arm to compare to. So patients that you provide with some control treatment, so what you would consider the standard of care at that point. But in the whole program, we did have one cohort where we, next to the immune checkpoint inhibitors, we also administered myeloid dendritic cells. So the dendritic cells are really the orchestrators of the whole immune response. They stimulate the T cells, which are really the soldiers of the immune system. They stimulate the T cells to be active against the tumor. They can also present the antigens to these T cells. And so we were able to isolate specifically the needed dendritic cells from the blood using a leukapheresis. And then these T cells we administered together with the immune checkpoint inhibitors directly into the brain at the end of the surgery. And in terms of safety and feasibility, this was all comparable to whatever we did in all the other cohorts. But we did see that in this group, survival was better than in all the other groups. And you could consider that that group and the other groups have the same type of patients in them. There's no selection bias between that one cohort and the other cohorts. So to us, that means that the administration of dendritic cells and the combination of that with the immune checkpoint inhibition seems most promising, and it's what we will invest more into in the future. Because if there's one thing that's clear, it's that glioblastoma is really a very immunologically cold tumor. It's very resistant to immune therapy because it probably evolved in this way. Like it develops resistance to other treatments. Chemotherapy, for example, it will also develop resistance to immune therapy or to the immune system in general. And so to stimulate it to become active or to become, so the immune system can become active against it, more things are needed. Combination therapy is needed. So this means not only checkpoint inhibition and not only one checkpoint inhibitor, because there's different types, but 2 or even 3 checkpoint inhibitors, and there are more than 3 types, but 3 specific types, so anti-PD-1, anti-CTLA-4, and anti-LAG-3. This seems the most promising, and also to combine that with other modalities of immune therapy, like oncolytic virus therapy or dendritic cell therapy, as we just said, or that seems the most promising avenue, so to give a combination of all these modalities to really get the immune system to be active against the tumor. So within our study, we have several patients that have been treated since the beginning or in other cohorts, and that after many years of follow-up still remain progression-free. And this is, so these were patients with recurrent glioblastoma, so I think we can consider that it was the treatment that caused these patients to become progression-free. And so that means that in specific patients, we were able to stimulate the immune response sufficiently enough so the tumor wouldn't come back. And it also has been shown in studies of long-term survivors of glioblastoma that the tumor in itself, so the way the tumor cells look like and how the genetic material is set up, etc., that it's not much different between patients that have long-term survival and those that have shorter survival. So the big difference between all these patients is the way their immune system is active against the tumor. It keeps the tumor on the wraps, And in some patients, this can really mean a durable response for a long time, because when a tumor develops and grows, it's in constant battle with our immune system that tries to keep it down, keep it under wraps, and make it disappear. And the fact that a tumor is actually there means that the immune system lost. But if you are able to reinvigorate this immune response, then potentially you could find a cure or an immunity against further development of this tumor. So it must be admitted that in the study, and this is true in any study in glioblastoma, it's not the majority of patients that have this durable response, but if you see a response in any immune therapy trial, it's typically durable. So that means that there's not a lot of tendency of the tumor to recur. This is typically different when you have a chemotherapy that really was active. Then these responses, especially in glioblastoma, are typically not durable, meaning that after a couple of months, sometimes 1 year, the tumor does recur. So that's the big difference. And that's also the whole idea of immune therapy, to really have the own body battle against the tumor and keep this battle ongoing for the rest of the time so the tumor can't recur. But we are not there yet at this moment. So our study is indeed could be or should be considered a phase 1 study, but we made it an adaptive phase 1 study. And that means that a classical phase 1 study takes a specific medication and it gives it to 3 patients. And if these 3 patients support it well, then you increase the dosing and you give it in another 3 patients. And then if some start getting side effects, so then you go back 1 dosing, and so you determine the dosing. So we use the same schedule of having 3 patients at each time, but instead of always increasing the dosing, we started with adding medication for the next 3 patients. So not only 1 immune checkpoint inhibitor, but adding 2. Then in a following cohort, we started putting in a catheter at the end of the surgery as well, so you can continue the local administration every 2 weeks after that. Then, as I explained earlier, we started adding the dendritic cells. And this way of doing an adaptive sort of study, it gives you results quicker. Now, this might come across as a bit of impatience, but the problem is that a lot of things in glioblastoma research have gone through the classical phases of a phase 1, where the safe maximal tolerated dose is defined. Then a phase 2, where you sometimes have a comparison and you try to see in a small number of patients whether there is actually any hint of activity. And then when you think, okay, this is perhaps has activity, then you go to a large phase 3 trial, and then you have to do a randomized control trial. So this whole, and then when a phase 3 is positive, then it goes to market. But when a phase 3 is negative, you have lost 10, 15 years of time from the development until you know that the phase 3 is negative, and then you have to start all over again because you only answered 1 question: is this drug really active? So because there have been so many negative trials in glioblastoma, so many patients that underwent treatment that turned out to be ineffective, the whole concept of going through those classical phases is being taught. So people are thinking about it and trying to look whether it can be done in another way. And especially in the field of immune therapy, because there's so many changes, so many options. There's, as I said, the immune checkpoint inhibition, the different ways of administering it. There's the oncolytic virus therapy, the vaccination therapy. It could be a normal vaccination, could be local dendritic cell therapy like we did. And then there's the CAR T cell therapy and other forms of T cell therapy. So with that many options, it seems like a better idea to have small scale studies that can be quickly adapted to incorporate new methods, and then if you see a signal of good results, then you could move on to a larger trial to really demonstrate safety.
Thank you very much, Professor Duerinck, for this extremely interesting interview. Just a last question. Do you think that the research and the studies for glioblastoma and other relatively rare cancers are correctly funded? Are the main laboratories funding you and cooperating with you or with others, or are you depending mainly from public spending and donation?
So it only makes sense that for tumors that are less frequent, that there's less interest and thus less funding. We are to some extent depending indeed on donations from patients and patient organizations, and this definitely helps. But I must say that the national scientific organizations like Kom op tegen kanker or Stichting tegen kanker, Fondation contre le cancer, that they do a very good job in in making sure that the rare tumor types also get enough attention, because it would be very easy to only provide funding for very frequent tumors like breast tumor and colon cancer. But I have a feeling that the applications are mainly judged on scientific validity, and that in function of that, then the funding can be provided. So, of course, more funding would attract more people into the field and more research. But on the other hand, as soon as a company thinks that there's some interest or that it could be positive, that they develop a specific drug or a specific method, also from their side they will provide the funding. So if there would be more money in the field, then more people would be interested in it. But I still think that if there's good ideas and then the application for the funding, and like in the program that we did, there's a potential immediate impact on patient survival, then I think it is possible to receive sufficient funding. It can always be more. It would make things easier, of course. But I think that at least in Belgium, that if you have a good idea that's sufficiently well, that has a good foundation, scientific foundation, that you should be able to find funding.